Hey everyone, I wanted to help you walk through the North Valley real estate data question in homework assignment number 6 today. And there are some issues with the assignment on the back end, so I wanted to show you how to do it. And then you can input your results, and then if you're running into any errors or issues with this or any other question, please email me so that I can go in and I can fix it and give you the credit that you have earned. So the first thing we need to do in our North Valley real estate question is to develop a correlation matrix. And we're given a set of variables that we're specifically interested in developing this correlation matrix. So I've downloaded the data from the question, and there are several different data sets in the question. So there are several versions of the question. So if your data doesn't exactly match up with mine, that's not important. The method is what's important. So I'm going to develop a correlation matrix using the price, size, bedrooms, baths, and days on markets variables. Before I do this, I'm going to create a copy of this tab in Excel. So right click it, move or copy. And we're going to move this copy to the end. I'm going to click create a copy here so we actually see a new copy is created. So now I have real estate 18E, and then I have real estate 18E2. And this is the data that I'm going to use to create my correlation matrix. So I'm going to remove all of the columns that just are not important to what I'm trying to do. So record, agent, pool, garage, township, mortgage type years, FICO, and default are all the variables that I don't need to perform this analysis. So I'm going to delete these, and now I'm down to a set of 5 variables. To create the correlation matrix, I go to Data, Data Analysis, Correlation, I click OK. So now here for the input range, I'm going to highlight all of the data in these 5 variables. So A1 through E106, and there are labels in the first row, so I'm going to click Labels. And I'm going to have it create its output on this sheet. So I clicked Output Range, I'm going to click in this field, I clicked H1, so now the output of my result is going to be in this field. And we're a little smooshed over here because of the format of the data before, but now we have the correct correlation matrix. So what we see here is that the correlation between price and price is 1, but then price and size is 0.952. The correlation between the number of bedrooms and price is 0.840. These are the correct answers to put into your table in the Connect application. So then the next question asks, what independent variables have a strong or weak correlations with the dependent variables? And because their values are very large, we know that there is a very strong correlation between price and bedrooms, as well as price and size, and price on bath, but not so much on days on the markets because it's a smaller number and it's closer to 1. And then if a coefficient has a negative value, it would have a negative correlation with price. So price is our dependent variable, and we're looking at everything in terms of price. So the next thing we want to do is create a multiple regression, or in this case, a simple linear regression, but then we're going to try out a few other variables to see about converting it into a multiple linear regression problem. So in my example, I need to create a regression equation where price is my dependent variable and size is my independent variable. So I'm using size of the house to predict the price. To do this in Excel, I go to Data Analysis, I click Regression, and then for my input range, I'm going to highlight column C here. And then for my input range for the X variable, I'm going to highlight size. We have labels. The first item is a label of what is in that column. And then I'll have this show up in a new window, so I'm not going to do anything. I'm going to have it go to a new worksheet ply. So here's the summary output of the model, where we find that our intercept is minus 15,593.60, and then the effective size, so with each additional square foot, the price of a house would increase by 108.3536 cents. So that coefficient value for price, that minus 15,593, goes into the price box, and then in the size or whatever other variable you have box, you would enter in the coefficient for size, which we see here is 108.3594. And then to consider the strength or significance of the model, we want to look at the R squared value, which is the next part of the problem, and that is 0.906788, and we'd round that to 3 decimal places to include that in the homework assignment. Then the next piece is to try to find another variable that might increase that R squared value in our equation. And we can go back to our data set here, and we can try, the easiest thing to try is to see if bedrooms would increase that R squared value. So again, we can go into data analysis. I'm not going to change the input Y range. We are still trying to predict price, but now for input X, we're going to highlight both size and bedrooms. In Excel, all of your independent variables have to be right next to each other, so it's just easier to try with bedrooms next. And I'm going to click OK. And it has not had a very significant effect, if any effect at all, on our R squared value. It's still about 0.907. So maybe we want to now go ahead and try a different variable. So going back into my data here, let's just see if this variable for pool makes sense. So I'm going to copy it, and I'm going to insert it here in column E, because like I said, values your independent variables always have to be next to each other in Excel. Oh, we don't want to use solver. Going back into data analysis and regression, we can actually use the same input range for X because we are still using same columns D and E. We've just changed what stuff is in column E. So here we see we've got a bit of a difference in R squared. Now it's about 0.914116. So adding the pool to the regression equation makes a pretty big difference. And you'll have a couple options that it will suggest that you try to see how it influences your output. And then the final thing that you need to work with to solve this problem is to look at the histogram of the create a histogram of the residuals and figure out which one most closely matches the histogram that you were able to create, as well as plotting the residuals against the fitted value from the final regression of the equation to figure out which plot is correct. So to get these values under data analysis, we'll go back and do our regression again. But here we can choose we just want to see the residuals. So we can check this box, click OK, and these are now provided at the bottom of your output. You have your residual for each one of the different values. The histogram, you'll only want to look at the residual values themselves. When you plot the residuals against the fitted values, you use both column B and C to create a plot, and then you compare that with the plots that are shown to you in the problem. And that should help you navigate the North Valley real estate problem in assignment 6. Give it a shot. If it doesn't work out and you think you followed all of these steps correctly, do not hesitate to let me know. You've probably done it right, and we have to make sure that you get all of the credit that you have earned.